Otto cycle. Nicholas Otto. Nikolaus Otto was born in Holthausen, Germany on 10 June 1832. In his early years, he began experimenting with gas engines and complemented his first atmospheric engine in 1867. In 1872, he joined with Gottlieb Weimer and Wilhelm Maybach, and in 1876 developed the first four-stroke cycle internal combustion engine based on principles patented in 1862 by Alphonse Benau de Rocha. Although Otto's patent claimed to the Otto cycle and invalidated in 1886. His engineering work led to the first practical use of the four-stroke cycle, which was to provide the driving force for transportation. For over a century, Nicholas Otto died on 26 January 1891. Induction stroke. The induction stroke is generally considered to be the first stroke of the Otto four-stroke cycle. At this point in the cycle, the inlet valve is open and the exhaust valve is closed. As the piston travels down the cylinder, a new charge of full air mixture is drawn through the inlet port into the cylinder. The adjacent figure shows the engine crankshaft rotating in a clockwise direction. Fuel is injected through a sequentially controlled port injector just behind the inlet valve. Compression stroke. The compression stroke begins as the inlet valve closes and the piston is driven upwards in the cylinder. Bore is the momentum of the crankshaft and flywheel. Compression in a spark ignition engine is used to force the oxygen and hydrocarbon molecules of the full air mixture into close proximity with each other. This not only raises the temperature significantly, the work of compression is converted into heat, but the action transforms the mixture from something that is extremely difficult to engine under normal atmospheric conditions into something that will burn rapidly after being ignited with used spark. Unfortunately, with lower unleaded octane fuels and high compression radius, it is possible to generate sufficient heat during compression for the mixture to auto-ignite, terribly effectively limiting the practical volumetric efficiency of the Otto cycle. Spark ignition. Spark ignition is the point at which the spark is generated at the sparking plug and is an essential difference between the Otto and diesel cycles. It's made to be considered at the beginning of the power stroke. It is shown there to illustrate that due to the flame propagation delays, spark ignition timing commonly takes place 10 degrees before TTC during idle and will advance to some 30 or some degrees under normal running conditions. Power stroke. The power stroke begins as the full air mixture is ignited by the spark. The rapidly burning mixture, attempting to expand within the cylinder walls, generates a high pressure which forces the piston down the cylinder bore. The linear motion of the piston is converted in a rotatory motor. The rotational energy is in part which not only provides power to the end use, but also overcomes the work of compression and mechanical losses incurred in this, like for example, valve opening and closing, alternator, fuel pump, exhaust stroke. The exhaust stroke is a critical to the smooth and efficient operation of the engine that is part of induction. As the name suggests, it's the stroke during which the gas formed during combustion are ejected from the cylinder. This needs to be as complete a process as possible, as any remaining gas displays the equivalent volume of the new charge of full air mixtures and leads to a reduction in the maximum possible power. Turned exhaust manifolds have to maintain the momentum of the gas during the stroke to assist in the removal of the exhaust gas. They can also be tuned within the maximum power rep range to create reflections or standing waves at the exhaust port to prevent some of the new full air mixture from disappearing through the exhaust port during both overlap. Exhaust and inlet valve overlap. Exhaust and inlet valve overlap is a transition between the exhaust and inlet strokes and is practical, necessary for the efficient running of any internal combustion engine, given the constraints imposed by the operation of mechanical valves and the inertia of the air in the inlet manifold. It is necessary to begin opening the inlet valve before the piston reaches top dead center (TDC) on the exhaust stroke. Likewise, in order to effectively remove of the combustion gas, the exhaust valve remains open until after TDC. Thus, there is a point in each full cycle when both exhaust and inlet valves are open. The number of degrees over which this occurs and the proportional split across TDC is very much dependent of the engine design and the speed at which it operates. And this is an animation of the Otto 4-stroke cycle. Thank you for the attention.